are a lot of ways you can get hurt in a machine shop. The very environment can be hazardous, for example, if it's not well lit or if the floors are dirty. The machines themselves are inherently hazardous, with rapidly spinning bits and blades and workpieces rotating at high speed. And the operations performed can be hazardous if they are not done correctly. Most of these hazards cannot be eliminated. So to work safely, you have to recognize what the hazards are, and you have to constantly follow good work practices to avoid them. We're going to examine many specific kinds of hazards in detail. But first, let's take a look at some basic safety requirements for working in the machine shop. These will apply to you no matter what machines you use or what operations you perform. Dressing properly is a fundamental safety requirement for working in a machine shop. If you're wearing a long-sleeved shirt, button the sleeves securely or roll them up to prevent them from becoming entangled in machinery. Since buttons can come loose unexpectedly, rolling them up is preferred. To be safe, roll them up above the elbows. Ties, jewelry, and watches should all be removed. They may become entangled in a rotating part, pulling the person into the machine very quickly. Each should be placed in a pocket or stored until leaving the work area. For the same reason, work aprons should be tied in the back, not the front, and the string should be kept as short as possible. Short strings tied in the back are unlikely to be caught in machines. Many machine shops also require all personnel, male, female, and even visitors, to wear hair nets. Hair, like sleeves and apron strings, can become entangled in rotating machinery. Another basic safety requirement is to use the proper personal protective equipment, or PPE. Safety glasses are fundamental. No one should be in a machine shop without eye protection, because chips and broken tooling from machining operations can fly anywhere, not just toward the machine operator. Most facilities have specific rules about when safety glasses are to be worn and when goggles are to be worn. Make sure you understand the rules and make sure you follow them. Gloves are not normally worn during machining operations because a sense of feel for the work being done is often important. However, they should be used when handling large pieces of rough stock, and cut-resistant gloves should be used when changing saw blades. Gloves may also be required when handling workpieces still hot from machining operations. Hearing protection is often used during production work in a machine shop. It is normally not required for most simple maintenance and repair work. However, at your facility, earplugs or other hearing protectors may be required in the shop at all times, or they may be required while doing specific operations. Make certain you know when you should be using hearing protection. Then use it. Proper footwear is also important. Sturdy steel-toed shoes will provide protection from falling tools and pieces of metal. Most steel-toed work shoes will also have thick soles, and these will protect your feet from sharp objects on the floor. The final basic safety requirement is to work in a way that puts the least amount of stress on your body. You should always try to work without straining your body's muscles, tendons, and ligaments. Your wrist and your back are especially vulnerable. To avoid injuries, it's important to use both your wrist and your back in their natural positions as much as possible. This is especially true when the force you exert is great. For example, when tightening a vise, keep your wrist straight for that final tightening, or use a wooden mallet instead. A couple of firm taps is just as effective as tightening by hand and takes only a few more seconds. When lifting any weight, it is very important to keep your back as close to its natural curve as possible. Keep the weight close to your body and try to use your legs to do most of the work. Even lifting small pieces of stock by bending at the waist can cause back problems because the strain on your back is multiplied. Lifting a 10-pound object at arm's length puts about 100 pounds of force on your lower back. Over time, if the strain is repeated again and again, serious back problems may develop. When lifting heavy objects, it is especially important to use good lifting techniques. If the object is very heavy, get someone to help you, or use a hoist or lift to do the work for you. Now let's take a closer look at the particular kinds of hazards you'll encounter in the machine shop. First of all, the shop environment itself requires consistent attention. Thorough, routine housekeeping should be a basic part of all work performed in a machine shop. Keep the floors clean. Clean up oil, grease, or coolant spills immediately. Never leave stray pieces of stock on the floor, and keep all dirt and debris swept up and disposed of properly. The main lights for the shop should provide plenty of illumination. Make sure the immediate work area is well lit, and replace any burned out work lights before you begin an operation. Also, all lights should be kept clean. Even a thin coating of dust will substantially reduce the amount of light at the workplace. Performing accurate machining work safely requires a high level of illumination. When machines are not being used, work surfaces should be kept clear and clean. Do not start an operation if chips or other debris are present, or if any materials you will not be using are left from a previous operation. And be sure you clean up when you're done, so the machine can be used again without delay. Disposal cans should be located in designated places with easy access throughout the shop. Make sure all tooling is properly stored in whatever bins or holders are supplied. Tooling left lying around can be damaged by contact with other tools, or it can fall on the floor. Any dull, damaged, or broken tooling should be removed from service and placed in a designated area for resharpening, repair, or replacement. All stocks of materials and supplies for machining operations must be stacked or stored properly. Do not store materials in aisles, and never block an exit or an entrance with materials, not even temporarily. Try to confine any machining operation to its marked workspace so other workers can move through the aisles safely without being injured by ongoing operations. When work cannot be kept within the designated workspace, always mark the area off clearly so others are well warned of the hazard. Every machine in the machine shop presents its own particular set of hazards. If you expect to work safely, you must be aware of what they are and where they are located on the machine. Generally, these hazards fall into three categories: mechanical, chemical, and electrical. We'll examine each of them in turn. Avoiding mechanical hazards requires attention to four main areas: points of operation, nip points, shear points, and power transmission points. Most machine tools present an obvious hazard at the point of operation, where the cutting tool actually penetrates the work. Points of operation all have sharp tooling or workpieces moving at high speed. They all produce sharp chips that can penetrate the skin easily, and they all get hot while the machine is in operation. Sometimes both the tooling and the workpiece get hot enough to burn fingers even after the operation is complete, so be careful both during and after the operation. Nip points occur where two surfaces are in contact with each other and at least one of them moves. An in-running nip point, like the point where two gears mesh, pulls things in, like tools, clothing, or fingers. Nip points must be avoided. Shear points are also common in the machine shop. These occur when one component moves past another, like the carriage on a lathe. In many machining processes, shear points are power-fed. The shearing action occurs under the power of the machine at a preset rate. Sometimes shear points are created when operating machines manually, for example, when lowering the frame of a horizontal bandsaw. Power transmission points in the machine shop are usually associated with gears, belts and pulleys, shafts, cams, and other means through which the power of the machine is transmitted to the point of operation. Nip points are often located at power transmission points, but it's also important to remember that all power transmission points involve parts that operate at high speed. Stay away from them. You can be injured just by touching a moving drive belt, even if you are not pulled into its nip point. In the machine shop, guards and safeguards provide protection from most mechanical hazards. Guards normally cover belts, gears, and pulleys, so dirt, clothing, and tools are kept out of the operating parts of the machine, and the operator is protected from inadvertent contact. Never operate a machine until all guards are in place. Doing so is dangerous, not only to you, but to other workers in the shop, as well as anyone else walking past. When making operating changes that require removal of the guards, always lock out the machine first. Then close and secure the guards before removing the lockout and re-energizing. In addition to these kinds of guards, most machines offer additional protection. Typically, these are chip guards on lathes and milling machines, and blade guards on saws. To provide protection, all guards must be in place any time the machine is in operation, regardless of whether or not you are actually machining a workpiece. And never reach over, beyond, or around a guard while the machine is operating. Safeguards are also used to provide protection. When activated, often by a guard being removed or opened, they prevent the machine from being operated. For example, vertical band saws typically have interlocks which prevent the saw from operating while the wheel guard doors are open. Never rely on an interlock to keep a machine de-energized as you work. Interlocks can be made inoperable by chips or other debris. Always lock out. Locking out properly protects you against the unexpected startup of machinery. In nearly all cases, you will not have to decide when a lockout is required. Most machine shops have firm requirements, often in writing, that tell you when a lockout must be performed. It only takes a minute, and it could save your life. Another kind of machine hazard is chemical. Coolants are often used during machining operations, sometimes misted across the workpiece, other times flooding it. Cutting fluids are also frequently used during machining. Usually, the fluid is squirted directly onto the point of operation. It is important to avoid inhaling misted coolants as well as fumes that rise from cutting fluids. You should avoid extensive skin contact with both, because repeated exposure can cause skin irritations in some people. Remember, too, that some coolants are recycled extensively and may develop bacterial contamination, which can infect cuts or open sores on the hands and face. Both coolants and cutting fluid should be washed off the skin as soon as possible. While normal accumulations of grease, oil, and grime from handling machine shop workpieces are not usually a problem, you should make sure your hands stay clean enough to handle tooling and operate the machinery without fumbling or slipping. Take the time to wash up when you need to. Machines can also present an electrical hazard. Loose, frayed, or broken wiring may short internal components to the machine casing. If you ever suspect an electrical problem with a machine, maybe it gave you a mild shock, or maybe the switches are not working correctly, stay away from the machine until it can be checked. Many hazards in the machine shop arise because of the operations being performed. Several of these are common to all machine shop work. All machining operations produce metal chips, some in small slivers, others in long coils and strands. You should never touch them with your bare fingers. Fine chips from a bandsawing operation can penetrate the skin and be difficult to dislodge. They can cause infections. Chips from other operations, especially milling and lathing, are often razor sharp and frequently very hot. Never brush away chips with your bare hands. Instead, use a hooked rod to remove long spiral chips and a brush to remove smaller chips. When working with cutters and other tools in the machine shop, careful machinists place them all together on a cloth-covered workboard, never on the machine. This protects both the tool and the machine. Placing tools on machining tables or laying them across the ways of a lathe may damage the tool as well as the machine. Sharp tooling can raise burrs on the surface of the table or on the ways, and small nicks may be gouged out. Repairs may have to be made before accurate machining can be done again, and the tool will certainly be damaged. Whenever handling sharp tooling, remember it can easily cut or nick your fingers. Saw blades should be handled with cut-resistant gloves, and drill bits and lathe cutting tools must both be handled carefully. Remember, if the tool is sharp enough for the job, it's certainly sharp enough to cut you. While most tools for a particular operation should be kept together, one tool should always be separate from the other tools, the chuck key. Whether you use a chuck key on a drill, a mill, or a lathe, you should always return it to its proper place and certainly never leave it in the chuck. It will be thrown out when the machine is started. The rule is never let the key leave your hand until it is returned to its proper place. No matter what operation you're performing, always stop the machine and make sure it comes to a complete stop before measuring a workpiece or making adjustments. When performing a series of routine operations, it is easy to let yourself fall into the bad habit of trying to anticipate the moment when the machine will stop, then moving in to take measurements or make adjustments too soon. Reaching into the rotating part of any machine before it has completely stopped may cause serious injuries. Do not rush. It's also important to proceed methodically when working with multiple workpieces. Take the time to arrange both the rough and the finished workpieces so they will not fall and be damaged. Finally, remember that many injuries occur in a machine shop when people are not concentrating on what they are doing. Many kinds of distractions can disturb your concentration. For example, if you feel you cannot ignore someone who comes up to talk to you, stop what you are doing. Do not attempt to carry on a conversation and work at the same time. You can also be distracted when you have other things on your mind. If you've had an argument and are angry, or if you're thinking about what you'll be doing after work, you will not be able to concentrate on the operation you are performing. People also get injured when they are performing a task that is very familiar. For example, if you've tightened down a lathe tool post 100 different times and never had a cutting tool come loose, you may become careless and neglect to tighten all of the bolts. One loose bolt may be all it takes to send a sharpened steel tool flying across the shop. The point is, you must concentrate on your work at all times if you expect to avoid an accident. In this program, we've looked at basic safety practices that are required whenever you work in a machine shop. We've also seen the 3 kinds of hazards that are common to all machine shop work. And we've demonstrated good work practices that will help protect you from those hazards. Many injuries occur in machine shops. The only way to avoid them is to remember what the hazards are and to follow good work practices consistently.